Hi, this is a brief review on how to use your graphing calculator to find key characteristics of graphs. Today in class, we graphed a cubic function for the volume of a box. We had x times, which was the height, times its width, which was 12 minus 2x, times its length, which was 18 minus 2x. And this was from problem number 1 in chapter 3, lesson 1. And what we did is we plugged in this into our calculator, and we first just looked at it in our normal window, which was a 10 by 20 window, and we saw just these two vertical looking lines. And then problem number 4 in our book said go to your window and actually change your x maximum value to be 15 and change your y min to be negative 400. Now negative, again, use this symbol down here, 400 up to positive 400. And then we hit graph. And so what we saw was we saw our cubic function go up, go down, and then increase again. And so it asked us to identify some key characteristics of our graph. So one of the things that we wanted to find was our y-intercept. And it's kind of hard to tell just by looking at this graph. So the first thing you want to do is you just hit trace, and you'll see a flashing cursor, and you know that your y-intercept happens when x is 0. So we said if you push trace again and you just type in 0, it will show up that x equals 0, and then you just push enter. So we had this equation, this was our window setting, and now we're just talking about how do we find our y-intercept. And again, you do that by doing trace, you type in 0, and you push enter. So our y-intercept is 0, 0. The next key characteristic that we talked about was our x-intercepts. Where does our graph cross our x-axis? Well, we clearly know one of them at 0, 0, but there are two more. And we don't always know if they cross at whole numbers or integers. So in order to do that, we said you're going to have to hit second trace, and you're going to have to pick number 2, that 0 option. When you push enter, it's going to ask you 3 questions. The first question is, what is the left bound? That basically means if I'm looking at this x-intercept, I need my cursor to be to the left of it, and it currently is. And enter is our way of saying yes. Now I need my cursor to be on the right-hand side because it says right bound. So I can either do that by moving my cursor, hitting the right-hand button, until it's to the right. Again, here's my point that I'm trying to find. The cursor is now flashing to the right of it. I push enter, and I can see 2 little arrows. If you have a color calculator, it will give you 2 vertical blue lines, or whatever color lines you have. And now I have to guess, and the guess, I just want to get fairly close to that point and push enter. And it now tells me that a second x-intercept is 6, 0. Our third x-intercept is over here, and we just repeat the process. So we do second trace, we go down to 0. It will ask us the same 3 questions. Is your cursor to the left of this point? And you push enter to say yes. It now make my cursor go to the right of that point. And it's, again, as soon as it's to the right of this point, you push enter to say yes. And then you guess the point, and you just push enter to guess. And it tells me that my third x-intercept is 9, 0. So we had 0, 0, 6, 0, and 9, 0 for x-intercepts. The other things that we talked about in terms of our calculator were finding the maximum volume. So that would be, what is that point way up here? And we again did second trace. We went down to, obviously, the one that says maximum. It will ask us the same 3 questions, left bound. So we want our cursor to be to the left of this peak. Now, I could use my cursor and arrow over, but sometimes that's kind of far away. So you could also pick a value, an x value that's to the left. For example, an x value that's to the left would be 0, and I could just type in 0. Notice it shows up at the bottom and push enter. And now my cursor's to the right, or jumped over to that point. Again, I can use my arrow keys to make it go to the left or the right of my peak and push enter. And then again, I have to guess what's my maximum somewhere over here, push enter, and it will find that my maximum was, if I had a height of 2.35, the maximum volume that we saw in class was 228 cubic inches. So that's how we use, again, the second trace feature to find key characteristics of the graph. The only other calculator thing that we went over to in class was to find a specific solution. And in problem number 5, they said we would like to know how tall does the box have to be in order for the volume to be 100. And so because we know that y was our volume, we had this equation for volume. But then they're asking us to find the volume when it's 100. So we can go to y2 and actually type in 100. And what that's going to do, if I push graph, is it's going to graph a horizontal line through the points of my graph where the volume equals 100. And we see that it will cross 1, 2, 3 times. And we can't exactly count that out or see the exact number, so we again are going to go back to second trace. And since we have two graphs, we're going to go down to intersect, because we want to find the 3 intersection points. So you push enter, and it's going to ask you a series of questions. Again, it's going to ask you, is this the first curve or first equation? And you say, look, yep, at y1, first equation, so I push enter. Is this the second equation? Yep, that's the second one I entered in. Push enter. And what it's going to do is it's going to say, guess an intersection between those two lines. And so I'm going to guess that there's one somewhere over here, and I'm going to push enter as my guess. And it turns out that if I made my height of my planter box to be 0.54 inches, the volume would be about 100 inches cubed. Again, how do you find out all of the heights? You do second trace, go down to number 5, press intersect. Is this your first equation? Push yes, it enters yes. Is this your second equation? Push enter for yes. And now we want to guess our second intersection point, which is over here. And it turns out that if we made our box, again, that 4.76 inches in height, then the volume would be 100 inches cubed. And we could do it for our third intersection piece. So again, go down to number 5, press enter, first curve, press enter is yes. Is this your second curve? Yes. And we want to find out this intersection point right here, and push enter. So it's also telling us that we could have a x value be 9.697, and we would get a y value of 100. We talked about how this point, though, doesn't make sense in terms of creating that planter box, because you'd be taking more out for the height than was possible. So only these first two intersections are actually answers that are relevant in our context. Algebraically, this is still an answer and an intersection, but it's not an answer within context. So those are the key features that we used in class today, again, all of which are found under second trace. We found value, we found zero, you can find minimum, maximum, and intersect. And we're going to continue to use those in our journey through Chapter 3, as well as we continue throughout the rest of the year. Thanks.